So welcome to our session on normal distribution. Every statistician must be able to understand this particular topic. It distinguishes you from everyone else because you need to understand approximations, probability. So we're going to look at what is called normal distribution, but we'll start with the basics of understanding this table, which is called our normal distribution table. So normal distribution is firstly with the following properties. Number one, it is bell-shaped, as you can see. Number two, it is asymmetrical. Number three, the area under graph is equal to 1. Okay, so here there's 0.5 and the other side is 0.5. So this area is adding up to 1. All right. So, and the tails don't touch the base. So this is what you need to understand about normal distribution.
So always the tails don't touch the base. What happens if they do?
The infinite. So the tails are infinite. But if we draw them, they touch, you're not going to penalize. I'm just trying to give you the characteristics. So these areas are infinite. They're 50-50. Then we have what we call the standardization formula, which is given by x minus mu over standard deviation. If you have a sample size, it's simply x minus mu over standard deviation square root of n. All right. So let me now start with the basics of learning how to read. Teach you how to read the tables, the normal perspective to reading from inside the table. 1.23, 2.33, then let's go to 1.96. So when you're reading 1.23, you go under 1.2. These are the first two numbers, and 0.03 where they meet. So we'll go to the table here and check out the reading there. So 1.2 is somewhere here. 0.03 is here. So when you trace, I hope this is visible enough. So when you trace, you discover that it's meeting where? 0.8907. So this means 0.8907.
How did we find the 0.33 again?
So how did you find the 0.89?
No, 0.3.
Number here. The 0.00, the last number is 0.03, just 1.2. When you add 1.2 in 0.03, it will give you 1.23. So how do we read this one? 2.3? 3?
That will be
Check under 2.3.
0.33.
2.3 and 0.03. 2.3 and 0.03. All right, so we do the same. And you go here, look for 2.3.
2.3.
Then under 0.103. So 2.3 and that's 0.03. You get 0.9903. Are we together?
Okay.
How about this one, 1.96? Where do we go to?
So that would be, I think, 1.9 and 0.06.
Excellent. So 1.9 and 0.06. So 9, 0.06.
Mm.
What is the reading?
0.9803.
97. So 97.
0.0, oh, 0.9750.
Yes. 0.9750. How about if you asked, is it just 2? Is it 2? Just go to 2.0 and then choose
Just what? So
2.0
it will be 2.0, yeah?
under 0.
And
So
then 0
is it,
under 0.
yes,
Oh, okay.
2.01 under 2.0 under 0.01. 2.05, yeah. So 2.0, 0.9772.
Mm.
You get it?
Yes.
Now let's do the reverse. Suppose you're given a probability of 0.9750. Find Z. So you're doing the reverse. You're going to under this one. Look for it. 0.97.
You're going to what?
You're going in reverse. You look
Mm-hmm.
at the
So
number.
if you're given the probability, yeah?
Yes, you're given the probability. So you go there. This is 1.9 and
Mm-hmm.
0.6. So this is
0.6.
1.96.
So Z is 1.9.
Yes, 1.96.
Oh, okay.
How about if we landed here? What is the Z here?
So then our Z would be 1.47.
Excellent. 1.47. How about if we landed here?
That would be 2.38.
Excellent. So sometimes you may not be given an exact probability. So say 99.10. You get the closest. Which one is close to 99.10?
If you're given what?
If you are asked to find 0.9800, let's look for
Oh,
0.
so like, let's say it's not there, so you get something that's closest to
That's
that.
closest, yes.
Ah,
0.9800. Let's check for it which one is close. They're in ascending order.
0.9800.
This one here.
The
So
one 0.97. We said which one?
this one
This
2.05.
one 0.9798.
Yes. People will go for this.
Oh,
You be given max, but it's not the closest.
okay.
Closest is this one here. This one is more pretty. This one is
So that one we can't get 0.980 because it's more than what we're looking for. At least you get something that's less. So
yes.
what happens if we get that one? It's wrong.
Check on this one.
Which one? The 0.9624.
Yes, try to find this one.
It's not there. So
Mhm.
the closest I would get. I'm not seeing it here. 0.9624. It's not there.
So which one is the closest?
0.96 no, 0.564. 0.9564.
9625 here.
Oh, okay. No, I've seen this. Okay, yeah. I was confused. I've seen it.
Okay.
How is arranging? Okay.
Yeah, in ascending order.
Oh, okay.
Mm.
Oh, okay.
Mm.
So the closest is 0.9625. So
Mm.
our Z is 1.778.
Yes, 1.78. Now there are special ones which are in between. For instance, 0.9500. So when you go here, you discover that it is between these two, this one and this one. So which one?
Which one?
This one is
0.1.
95.
0.
So you have three options. You pick any of them. So 1.64, 1.65, but the most exactly, you pick the lowest one and add a 5 at the end. So it becomes 1.645. So here, you add a 5 at the end. So 1.645. If it was between 7 and 8, 1.64, 1.665. Just add a 5 on the lowest
You
one.
get the smallest one and then add the 5.
Yes. Yes. So yeah, if it's in between two of them. So this one would be 1.645. If it's exactly in between. Okay. It's exactly in between. For instance, 9930. 9930, where is it?
99 what? It it's I would say it's in between 0.9929 and 0.9931. So I would say it's 2.3. So to be 2.35. Wait, when adding the 5, like you add the 5, so it's not confusing.
Where are we now?
We're looking for, is it 9930, right? So I'll say 9930. I would say it's between 9929 and 9931.
So you pick the smallest one and add a 5.
So you get this. So to be 2.3. Now like 2.35, and then like I add the 5 to the 5 that's already there. Also it's 2.355. Because if we're doing it the normal way, if we're not adding the 5, I would say it's 2.35. Now since we're adding a 5, is it you add it to the already 5 that's there, or
So what's the answer? So what's the answer? Are you there?
yes, I am.
So we'll look at 9930. So you go between 9929.
9929 and 9931.
So it's exactly in between. So you pick the smallest one and add a 5. So you add a 5 here. So this
So it would be 2.4.
2.45.
2.045.
Mm.
So isn't it the same, like even without adding the 5, wasn't it going to be 2.45?
If you didn't add it, it would have just been, no, sorry, it's 2.455.
455. Yeah.
Yes, 2.455.
Yeah.
Now, in an example, we are given, suppose your mean is 10, your standard deviation is 3. Then you're asked to find the probability of x is greater than x is greater than 16. Probability x is greater than 7. Probability x is less than 15. Okay, so now that you've learned how to read, you can use the formulas and the following steps. Okay, so there are 3 steps that you need to do. Okay, are you there?
Yes.
Step 1, you need to learn how to illustrate. Okay, step 1, you need to know how to illustrate. Step 2, you need to know how to shade. Step 3, you need to also know how to standardize. So in that case, let's try to do the following steps. Number 1, illustrate. So 10 is in the middle here. 16, the number line is there. Yes. 16 is here. So step 1, you use ISA. Okay. Illustrate, shade, standardize, and apply. So 16 is there. What sign is there? Greater. So we're going to shade to the right. So we have shaded. Then standardize. The form of standardizing is what? Z is equal to x minus mean over standard deviation. So our x is 16. Our mean is 10 divided by the standard deviation is what? 3. 16 minus 10, 6. 6 over 3 is 2. So the reading from here to here, we check under 2. What is the reading for 2? So 2.0 is 0.9772.
We check what?
Yeah.
Oh, we got the table.
Yes.
So what's the reading for 2?
Yes, 2.0, yeah. 0.9.
2.0.
0.9772.
0.9772, yeah.
Okay. 0.9772. So it means from here to here is about 97%. So to get this reading here, since the read area is 1 total, so here we simply subtract 1 minus 0.9772. You get what we're subtracting, eh?
No, I don't.
All the readings that we're getting from this table here, for instance, means the reading starting from here up to. So if it's up to 2 here, it means this reading here that we had here, it's about 97%. If we get a 3 could have been 99%, 3.6. So it ends at 3.6 somewhere there. Here, 3.6. So this is 100%. So if you reach at 1, at 1 here, it means the percentage is 84%. If you reach at 2, it means it is what? 97.7%. So these are just percentages. So in this case here, the 2 reading. So this is, when you standardize, this is 0. 16, we said it is a 2 when you standardize it. So the reading at 2 there will be 0.9772. So from here to here is 90%. What is the remainder? 10. From here to here is 80%. What's the remainder? 20. From here is 97.72%. What is the remainder? Subtract from 1. You get?
Not really. Too confused.
Okay, you get it along the way. So let's try now greater than 7. What we do using ISA, we illustrate. Our 10 is here. We can't put 7 this side, we put 7 this side. Okay. Then shade. Saying greater than 7. 7. So we're shading to the right because it's greater. Okay.
So you shade up to the far end there. I thought you'd only be shading that area there.
You shade until you can shade no more.
Oh.
Okay. Maybe let me start as follows. Okay. Then you standardize. How do you standardize 7? 7 minus 10 divided by 3. So this is negative 3 over 3. We get a what? Negative 1. So this is negative 1. The negative side just shows you. So whenever the shading is big, you read direct, don't subtract. Whenever the shading is small, you subtract from 1. That is my idea for you. Because this shading is bigger than.
Whenever the shading is big, you don't subtract to add 1.
No, you just read it directly.
You just read it. Don't do anything, just read it the way it is when it's big.
Yes, when it's small like this one here,
when it's small,
you subtract from 1.
You subtract from 1.
So here, this reading is big. So let's check on 1. What is 1.0? 1.0, what is the reading?
1.0, 0.84.
Yes. So 0.84. So x greater than 7 is 0.84.
1.
Correct. Okay, let's try x is less than 6. Step 1.
We illustrate.
Put in there. Why do you put 6? Where are you shading? Left or right?
Left.
Good. What does the shading tell you?
We subtract from 1. Okay, after the shading, let's standardize before editing. So that will be 6 minus 10.
So standardize the 6, eh? So 6 minus 10 divided by 3, which is negative 4 over 3, which is negative 1.33. So this is 0, this is negative 1.33. So the shading, what are we going to do? The answer we're going to find?
Subtract from 1.
Excellent. Subtract from 1. So you go 1.33. So 1.3 and under 3. 1.9
Under 3.
is 1.33. So 1.3. When you divide 4 divided by 3 is 1.333. So you get to the nearest whole number. If you have 1.
Oh, which is like 1.3, which is 0.3. Okay.
1.67 to the nearest 2 decimal places.
Our previous one was what was our previous one again? I didn't write it down.
It was exactly 7 minutes. It was exactly
It was
1.
exactly 1.
And this one was exactly 2.
2.
But
Oh,
if you
okay.
carry 1.33, it would be 1.33. 1.666, it would be 1.67. 1.888, it would be 1.89. Make sure it's the nearest whole 2 numbers. So this 1.33. That's how you went to 1.33. 1.3 under 3 is 0.809082. So meaning this big part is 0.9082. This is a big part. The small part here we're going to subtract. So from 1. So 1 minus 0.9082. So 1 minus 9082. So here we're going to have 0.0918. Okay. So to try it, lead me with this one. Let's see. X is greater than 19.
Oh, that's right.
That's straight, correct? Mm-hmm.
Okay, so X is greater than 19 will be on our right.
19 is here, all right?
Then when we shed,
Where was shading?
straight on your right.
On the right? Why right?
What is greater than?
Correct. What does shading tell you?
What does what?
The shading tell you?
It's greater than 19, so it could go
Small is
beyond that, right?
big. Is it small or it's big?
It's big.
The shading. That's the shading. Yeah.
So we can't go beyond that one. Oh, okay. Now I get it. Okay.
Right, so what's happening? We subtract the mean, the x minus mu over standard deviation 3. So here we're going to have 9 over 3. So what is our z?
Our Z.
Exactly.
It's 3. Yes.
So since this is small, what we're going to do is do what? Subtract 1 minus z, right? probability.
Mhm.
All right, so let's read. Give me the reading for 3.
Mm, 3.
So 3.0.
Zero,
Mm-hmm.
it's 0.9987.
Good. 0.9987. So I mean the reading from here to here is 0.9987. So what do we find for the other shaded region here?
This is where we now subtract from 1.
Subtract from 1. Excellent. So you get the procedure now because it's like a small read. It's only greater. You tell me that the shading is more than when it crosses the middle line here. So here it's a small shading. So it will be 1 minus 0.9987.
It's only big when it crosses the middle line.
So
Oh, okay.
yes, there are 4 shadings. You tell me which one is big, which one is small. So I'll tell you these 4 shadings. I'll tell you one, then you tell me the rest. Okay.
Okay.
1, 2, 3, and 4. So shading 1, I'll tell you 2 things. Number 1, the shading is small. Number 2, the sign is greater. Therefore, we subtract the reading from 1. Shading 2,
Setting 2 is the sign is less
good, less. We're going to the
and
left.
it's mhm.
Hmm?
Yeah, it's less and it's oh,
The
mm, the shading is small.
is so small. Therefore, we
There's
subtract
no need to. Yes, it's small, so we subtract from 1.
here.
Um, then for 3,
Mhm.
it's also less,
Is correct.
but the shading is big.
Therefore,
You get it the way it is.
redirect correct. And shading 4,
It's greater than
greater than
square
correct.
and big.
Therefore,
It's direct.
redirect correct. So you get it, eh?
Yes.
If you're being asked to say find uh, x is greater than 5. So what we do?
We illustrate just so we started.
Mhm.
We draw that line. So like the number is always 10 there.
No, it's a mean, whatever average
I
comes.
mean, okay, whatever, okay, yeah, okay. So I
And,
saying it's greater than
mhm.
x.
Where we're shading this side, right?
Mm-hmm.
Then the mean is always at 0, then standard is 5. So z would what? 5 minus 10.
Minus 10 over here. Plus
5
3.
over 3, what do we get? Negative 1.6666. What do we round it off? Negative 1.67.
6, 7.
So we read from the table 1.67.
Mm-hmm.
What is the reading? 9525.
Okay. When 1 point what?
9525.
6 first. We said 1.67. So it's 1.67 and then to 0.37. Okay.
Hello?
Hello.
Yes, yes. So what's the reading there?
Mm, It's 0.99525.
Yes, your point.
Yes. 0.9525.
Mm-hmm. 95.25. So what do? We subtract or read it direct?
Direct.
Excellent. So you see that it's as easy as that.
Yeah.
Now, lastly, you'll be asked to find the value of x for which we are greater by 5%. Find the x if 5% greater. Now, here is a skill that I was teaching you. So you remove the 5% here, 5%. So we know already here we have a 10. We're going the greater side because greater is on the right side. So when you remove the 5%, what remains here? Or let me say 2%. Find the value of x for which we are 2% greater. So we remove 2% here, we're going to remain with 98%, right? And 8%
Okay.
in terms of decimal point is 0.9800, all right?
Okay.
98% is 0.98, isn't it? Divided by 100.
Yeah. Yeah.
You check inside the table. I told you whenever you're given percentages, you check inside the table. 0.9800. Remember, we looked at it. The closest was which one? 2.05. Okay.
Mhm.
So meaning here our z is what? 2.05. So we're looking for x. So we know that z is equal to x minus mean over standard deviation. So 2.05 is equal to x minus the mean is 10, standard deviation is 3. So in cross multiply, so we're going to have 2.05 is equal to x minus 10. So when this comes this side, it will add 10 plus 3, 2.05. So to find our x, we evaluate, and this will be 10 plus 3 times 2.05, which is 26. X is 10. So this will be 16.15. So you get this? It's a lot to take, but this is where you are really tried. Okay. So any questions?
No, so far I'm okay.
All right, okay. So I'll send you homework based on what has been covered for now. So we end here. Have a good day.
Oh,
Maybe another class at 30 now. All
right. Thank you.
right, have a great day.